Ok, bom dia, pessoal. A vinheta foi no ar? Já? Ok. Tá, então estamos agora iniciando o segundo dia da 25ª Workshop de Engenharia de Requisitos, UER 2022, e a primeira sessão do dia é com o nosso palestrante convidado, o professor Daniel Amyot. Né? O professor Daniel Amyot, ele vai falar aqui sobre um tema extremamente atual, né, que são as questões lá de uso de contratos, ou smart contracts, né, no contexto aí de requisitos legais, né. Okay. Eu agora vou ter de mudar para inglês, né, porque ele está nos ouvindo, e vou fazer uma breve apresentação aí do professor Daniel Amyot. Professor Daniel Amyot, so Professor Daniel Amyot, he's a staff at the School of Electrical and Computer Science of the University of Ottawa, Canada. He has been there for 20 years, if I'm not wrong. So he previously was a senior researcher at the Mitel Network, which is a telecommunication company well known in Canada. Daniel holds a PhD in computer science and also a master's degree in computer science and a bachelor of computer science. So he's a typical computer scientist, but he's also a professional person. He has all the qualifications that are required in Canada to act as a professional engineer. So that was issued by the order, the engineer de Quebec. Okay, so he is also an information system professional. So he's a qualified, that is issued by the Canadian Information Processing Society. And a senior member of the IEEE, the Institute of Electrical and Electronic Engineers. He has played various roles in our requirement engineering community. For example, he organized the RE conference in 2015 in Ottawa, so he was the general chair. He was also in charge of the program committee in 2018. Also, the conference was held in Canada that year. And he is a member of the editorial board of some journals, especially the Requirements Engineering Journal of our field, and also a member of the SOCIN, which is the Software System Modeling Journal. So for some of you that are submitting papers to these venues, the Requirement Engineering Conference, the RefSpiel, also the journals, you probably may be evaluated by him. So be careful, right? He is interested in various topics, mainly related to software engineering, and he is well known for his work in goal-based requirement engineering. And he's done also a lot of contribution in business process modeling and mining. And more recently, he has focused on regulatory compliance, contracts, legal aspects. And he has contributed to healthcare informatics as well. He has a very strong publication record with more than 200 papers. And he's the main investigator that was behind the URN, the Unified the User Requirements Notation, that was part of a standard related to telecommunication. And he has recently focused on a modeling language, which is the subject of his talk today. And this Symboleo language is suitable for specification, for verification, and monitoring of contracts and legal contracts. And this is what he's going to talk about today, okay? So we are very pleased to have him here, and we would like to welcome him. And please, Daniel, you can now share your slides. Por favor, compartilhar agora os slides dele. Vou parar a minha apresentação. Okay? And so I'm stopping. And Daniel, now you can take over. Thank you.
Muito obrigado, Gelson. So it's my great pleasure to be here on this 25th anniversary of the WER conference. Bom dia a todos. My name is Daniel Amyot, and I'll be discussing over the next hour some work that we have done at the University of Ottawa on the development of the Symboleo language for specifying legal contractual requirements and generating smart contracts. So I hope that out of this presentation you will get some idea of how to create a domain-specific modeling language with respect to requirements engineering in that space. Obviously, there are many notions related to laws and contracts that have been investigated over the past 30, 40 years in the requirements engineering community. And those are very important because laws and contracts essentially provide requirements on how we should behave as individuals and as a society. Laws are also imposed by governments, and that's a difference with contracts, where contracts essentially result from some negotiation and mutual agreement of several parties involved. And contracts are much more frequent than laws, right? So many of you have been involved in many contracts over the years. They are smaller in scope than laws, and probably they have a bit more emphasis on time and deadline. So this is one characteristic of contracts that we will need to deal with in the next few minutes. Now, the work that I'm presenting today is the output of the work of many people at the Contract Specification and Monitoring Lab at the University of Ottawa. So there might be a few familiar faces here. So John Melopoulos is working with us at the university, Luigi Logrippo, Marco Roveri from the University of Trento in Italy. We've had several students helping us with developing that research program. Currently, Alireza and Aydin are submitting their thesis these days, and we have new students coming on board as well. Now, just in case you have to leave early, these are the conclusions of my presentation. We'll revisit them at the end, but essentially we're interested in engineering smart contracts as a kind of cyber-physical systems that monitor, automate, and control the execution of legal contracts. Symboleo, our language, is a formal specification language for contracts that is based on a conceptual ontology inspired from UFOL. It's also event-based and uses state machine and axioms to represent the semantic of the language. And some of the characteristics are also based on event calculus. And we support time and also subcontracting and other dynamic modifications. So those are unique characteristics of the language. I will be talking about two tools today. One is for verifying properties via a transformation to a model checker, new XMV. And this is useful for checking contracts against properties at design time. And we also have another tool for the generation of smart contracts on one distributed ledger platform called Hyperledger Fabric, where we're using JavaScript as the target language. And this is meant to enable the monitoring and partial automation of legal contracts, obviously at runtime. So this is what I will be covering over the next hour. Maybe some definitions would be helpful here, because we do make a difference between a legal contract and a smart contract. So legal contracts specify the terms and conditions that apply to business transactions. We often use natural language to describe them, so this comes with some ambiguities usually. They're difficult to analyze formally, both when we are designing contracts and also when we are performing or executing their many clauses. And obviously the problem becomes a bit more complicated in the presence of many documents, including a hierarchy of subcontracts, for example. On the other hand, smart contracts are programs that are intended to partially automate and control some aspects of those legal contracts that we've been discussing, and also monitor them for compliance with the various terms and conditions that they contain. Templates where we have parameters that can hold multiple values. This is an example of a meat purchase and sale agreement where we have some obligations regarding delivery of meat of a certain quality, payments given certain deadlines, some clauses related to the termination of the contract, who can cancel the contract, for example, and perhaps even confidentiality clauses at the end. So I could instantiate that contract template with specific values that will enable me to buy essentially some meat from Cordoba and bring this to Ottawa. And obviously, maybe there is no direct transportation from Cordoba to Ottawa, so I could have subcontracts along the way that will handle the transportation part of the initial contract. And perhaps, I'm going to use the train to bring the meat from Cordoba to Buenos Aires. And then I will, use a ship to bring this to the Halifax port in Canada, and use a van to bring this meat to Ottawa. So I would instantiate the transportation template 3 times with different values. And of course, this is meat, so we have to ensure that this particular asset, so this meat, is preserved under refrigerated conditions. It has to be frozen all the time. And this is where we start having interesting cyber-physical systems, because we need to monitor how cold the meat is across multiple transportations, multiple jurisdictions as well. On their side, smart contracts, they look like code, right? So those are programs, and there exists many programming languages, other general ones or domain-specific ones that enable us to code smart contracts and essentially store them on the blockchain platform so that we can avoid tampering with their content and execution. One of the most common language for this is called Solidity. It's meant to be used especially for the Ethereum platform. So now that we understand what are contracts and smart contracts, I'll give an overview of what we're doing in Ottawa, essentially. So what we want essentially is to enable lawyers and modelers to specify formally the content of contracts in such a way that we could use analysis tools to check them at design time, and also code generation facilities to implement monitors that will ensure compliance of contracts that are being executed. Obviously, this comes with related challenges, and another challenge is perhaps the use of some transformations to extract those specifications from natural language contracts, which are the common representations being used nowadays. So let's start with the first challenge, so the specification. And in this context, we need some sort of a language that will enable us to represent in precise terms and consistent terms the terms and conditions that we have in contracts, especially those that enable some monitoring, because this is our interest here. So we've essentially described three key requirements in our context for such a language. So it has to be expressive enough to formalize legal contracts from different domains, although we do not expect to cover all domains. So we focus mainly on business contracts instead of, wedding contracts, for example. Something that can lead to specifications that can be analyzed formally against the intentions of the parties involved, and also enable code generation for monitoring. So those are the three key things that have guided the design of our language. And the result is named Symboleo. So Symboleo comes from the Greek term that means a contract. And given that John Melopoulos is with us, this is essentially the name that stuck to our language. And the idea is essentially to have a way to capture the various parts of contract templates using our Symboleo language. So the presentation here is very small, but I will come back to the various parts of the Symboleo specification in a couple of minutes. Well, the main point here is that we have essentially domain aspects that describe what are the data types that exist in the context of the contract, what are the parameters of the contract, also what are the obligations that come with the contract, and perhaps additional constraints that exist. So those are some of the main things that we try to formalize in Symboleo. And to construct Symboleo, we've looked at dozens, if not hundreds, of contracts to understand essentially what kind of terms and conditions exist in that space. We've also got some inspiration from foundational ontologies like UFO, and also UFOL, which is the legal foundational ontology that has been created by people in Italy and Portugal mainly. We came up with this representation of the main concepts that we wanted to model to enable verification and monitoring. So we do have contract-related concepts like party, role, assets that vary substantially across contracts. We looked at various kinds of legal positions, so essentially modalities, to describe the various kinds of requirements that we find in contracts. The main one is certainly obligations. And we also have ways to modify obligations during the execution through powers. So powers will enable us to create new obligations or modify or suspend or terminate existing ones. Legal positions exist in certain contexts that we call situations. And situations will also help us capture and specify time-based requirements about specific time points, like a deadline or an interval of time. And those concepts essentially are borrowed from UFOL. So those are the concepts that exist underlying the specification language. Now, in terms of the I would say the runtime semantics of the language, we went with a state-based representation of how contracts, obligations, powers, events evolve over time. So we essentially focus on events because this is the kind of concept that will enable us to monitor the execution of contracts. So the interface between our smart contracts and the external world will be based on events. And events essentially will enable us to transition from one state to another for given obligations, powers, and contracts that we are monitoring. The content of those transitions essentially is the topic of various kinds of axioms that essentially formalize the transitions between the states of those state machines. And many of these axioms will be time dependent. And we are using essentially event calculus to enable the formalization of those transitions that are time related. We also have primitive execution time operations that will allow us to change who is responsible for certain obligations or powers. Is there transfer of liability along the way, or sharing of liability, which are often things that are required when you have subcontracts or if you substitute parties along the way. But do not read all of this. That's the topic of thesis and papers. The bottom line is that we're using event calculus. We have many types of analysis, including compliance monitoring, and we can handle many advanced dynamic aspects of contracts, which are very difficult to specify and analyze formally usually. Just to give you an idea of the use of these primitive dynamic operations, the idea here is to support, for example, party substitution, where one party of a contract is being replaced by another party during the execution of a contract. So essentially, we can define macros that represent party substitution and subcontracts and assignment of rights, for example, using those basic operations. So they're quite powerful. And we can also use them to do jurisdiction specific, I would say, functionalities, because in law, contract laws vary substantially across nations, provinces, states. So we need to be able to enable modelers to specify their jurisdiction semantics for very advanced operations. And essentially this enables the creation of macros for specific jurisdictions. Now, if I go back to the meat sale example, the idea is that we first describe what is the domain of the contract. And for that, we extend the basic ontology that I showed earlier. So this enables people to say, for example, that, okay, I will describe what is a seller, what is a buyer. Well, these are roles, and we can add attributes to these roles, right? So say a return address or the warehouse address as well. I can define enumerations, like for currencies. I can define what is the meat quality for my contract, right? So it's prime beef, AAA beef, something like that. And I can also do that with inheritance hierarchy. So we support inheritance essentially in the language so that we can define concepts on previously defined user concepts as well. So we define what are the basic concepts for that specific contract template at that level. And then we define, well, the interface between the contract template and its instances. So we essentially provide parameters for those contracts that can be used to instantiate different contracts and for different parties in here, for different buyers and sellers, for example, for different quantity and quality of means. The language enables also the declaration of internal variables that can be initialized as well with some of the values passed during the instantiation of the contract. we can also define preconditions and postconditions for the contract as well. So things that should be true before and after the execution of the contract. Now, the most interesting part is certainly obligations and also other modalities that we support. So obligations in our language have debtors and creditors. They also have antecedents, which are situations, and consequent, which are also situations. Powers also have the similar signature as well. Both of them can have optionally triggering situations. So under specific circumstances, an obligation might become active, or power might become active. And the powers can be things like, well, you know, in our context, I can suspend the delivery of the meat for whatever reason. I can terminate the contract for various reasons. So those are powers that can be enabled under specific circumstances. We also have this notion of surviving obligations, which essentially enable some obligations to remain after the theoretical termination of the contract. And these usually target non-disclosure clauses inside contracts. So they may last a bit longer than the official delivery of the meat, for example. At some point, we decided to formalize our language. So we defined a grammar for it. We use the Eclipse Xtext environment to formalize that grammar and to produce also an integrated development environment, an IDE, so an editor for the language that supports many features such as syntax highlight, code completion that is intelligent enough to understand types along the way, and various kinds of checks for well-formatted rules, and also for type checking inside the editor. So we have now a good environment to produce specifications that are syntactically correct and that comply with the static semantics of the language. So this is the language that we have. I'm midway through my presentation. Maybe now would be a good time to get a few questions, Gelson, if there are some questions available.
Okay, so if anyone is willing to make a question, you can use the YouTube, or for those that are in the Zoom session, you can open your mic. So Don Barry has a question.
Yes, Don.
Yeah, if I understand you correctly, you can, one of your programs can simulate the event that are taking place. So in effect, you can really put the ball in one court. So can you conduct what if kind of question with the software?
Yes, so I'm getting to the analysis part right now. So your question is a bit before that part of the presentation.
If you're going to answer it later.
Yes, so your question relates to analysis, right? So once we have that specification, what can we do with it?
Yeah, right? You can wait few more minutes, right?
So the answer is yes, Dan. So we have two tools for analysis. One that does exactly that. It's Prolog based. So we have converted the language into a Prolog representation to check what if analysis of specific scenarios, to check if they are leading us to the right states. But the better tool that we have, and that's the one I will present next, is using model checking to check properties at large. So with a wider coverage of the analysis.
Okay, good. We have another question from Julio. Giulietta, please go ahead. Julio, you have to. Okay, good.
Daniel, thanks. My question is the following: how do you compare? It's just to contextualize from the previous work from the Trento group with Nomos T in Desiré. I don't know if you recall those.
Yes. So Nomos T is more the legal level, right? So contracts are more specialized than laws. They have their own characteristics. They have their own concepts, because not all legal aspects are about time or assets, and those are essential things that we find in all contracts. Okay, so I would say that Nomos is wider in scope, as it addresses laws in general, but insufficient for contract specifically. And also Nomos and others will enable some analysis, but they won't support code generation the way I will show you in the next few minutes.
Right. So my next question I will leave for for after, because
Okay.
it's related to compliance. But okay,
Getting there.
getting there. Thank you.
I have a question, right? What about this transformation from natural language contract into Symboleo specification?
I have 2 slides on that, but this is work we are starting. So it's very difficult to automatically translate natural language contracts into that representation, because the styles that people use to write contracts differ substantially across organizations and governments.
Right.
So for specific domains, it will be, or specific context, it will be feasible to do so. But we only started last year to work on that, essentially that transition here.
Yeah.
Okay.
Graciela has a question in the chat.
Yeah, I'm waiting for the questions coming from the chat. Just a second. Before that, so there's sending me the question from the chat. But before that, I noticed that you are using event-based calculus, right? What about model type of logic representation in Olympics?
Well, we
about
look at various, deontic logics. We looked at Hefner's, Hoffeld's types of modalities as well. He has 8. Many of these approaches, again, target laws in general, whereas contracts are a bit more specific than laws in general. So we don't need all of that complexity. And our conclusions after several months was that it's sufficient to focus on obligations, because obviously all laws and contracts have obligations, and also ways to modify those obligations that we do through powers. So we don't need to go well beyond that. And
okay.
Of course, since we support negation as part of our propositions, we can also have obligation not to do something, for example.
Okay, we have thank you. We have a question from Graciela. She's asking how many keywords has this language Symboleo?
Keywords? I would say
you want to open your mic? You want to ask yourself? Let me see.
Yes, my question is because could they support this language? Could support every type of contract? Do you think that?
No. So we focus on a kind of business contracts that can actually benefit from monitoring. Right. So if I go to a restaurant and I buy something, I order something, I buy something, this is in a way a contract, but this is a one-time transaction, right? So those things are not interesting. We're interested in contracts that are a bit more long-lived, that have multiple opportunities for observing its progress over time and essentially detect violations along the way. And our hope, the big vision, is to try and prevent those violations from happening in the future. Right? So the idea is to monitor and see that, oh my God, that contract is heading in a very bad direction right now. So maybe we should raise the attention of the parties involved that they should do something about it. For example, as we're getting closer to deadlines.
Thank you very much. That's why I was asking for the number of keywords, because I think there are so many type of contracts, but if you are concentrated or focused on a certain type of contracts, it could be.
Yeah, because this language is being developed partly in a project that focuses on cyber-physical systems.
Okay.
So we have sources of events that are not just from people, but from sensors, right? So we want to automate more or less the monitoring of the execution of those contracts.
Thank you very much.
Okay, there is another question here. No contract is supposed to violate laws in the place where the contract operates. So how is this enforced? Example, tacit requirements.
So those are essentially what we call void contracts, right? So contracts that are invalid from the start. Right now, we are, that's the same issue with natural language contracts, right? So somebody somewhere with legal expertise, so lawyers, need to check that those contracts are in accordance or in compliance with the jurisdiction or the legal systems where they reside. There are many ways in which this can be done. One of them that we haven't investigated yet is to also encode laws as properties that could be checked against those contracts. So this is essentially one set of requirements for contracts, is that they should not violate legal requirements along the way. So we haven't reached that part yet. We just assume right now that the natural language contracts we start with are valid contracts, that they're not void with respect to the jurisdiction where they reside.
Okay, thank you. Go ahead with your presentation, please.
Thank you so much. So the second part, or the second challenge of that presentation, is the analysis of those specifications. And as I said, we have two tools, one that essentially looks at test cases, so sequences of events, and see where this is heading in terms of the states of the contracts and the obligations and permissions. But the one I'm focusing on is the more mature one, where we enable verification of specifications with model checking. So for those of you who haven't seen model checking, this is an algorithmic procedure that will enable the verification of specifications against properties. And very often those specifications are state-based. The properties themselves, in our case, since we have selected a specific modeling checking tool as a target, that tool is supporting a linear temporal logic, LTL, and compositional tree logic, CTL. And using those temporal logic languages, one can specify additional requirements on the specification, such as liveness properties, where we check that good things will eventually happen. For example, the meat cell contract eventually terminates. And also safety properties. So something bad will not happen. In our context, for example, in case of a late payment, the buyer cannot be penalized more than once. Okay? Or the normal payment and the late payment obligations cannot coexist at the same time, so that again the buyer cannot be charged twice. So those are all properties that I can express in temporal logic, and the model checking engine will be searching all the potential futures allowed by the specification to detect violating situations along the way. So those are very powerful tools. And the tool we selected is NewXMV. It's one of the best and most mature tools out there. This is the successor of the new SMV tool, for those of you who knew that tool 10 years ago. So NewXMV has its own input language. So NewXMV is both the name of the model checking tool and also of the input language. So it's a textual format. As I said, this supports LTL and CTL properties. And since this is a model checking tool, one nice thing we get is that if a property is violated, a counterexample will be generated. So we will have a trace that leads to the violation or an explanation of those violations. So there is a good match between the state-based semantics of Symboleo and the state-based representation enabled by NewXMV. So Alireza Parvizi Mosaïed developed in the past few years a tool called Symboleo PC. So it's a property checker that essentially takes as input Symboleo specification edited with our Xtext environment. So the parser is integrated. This generates Java/EMF objects internally. The tool takes also as input modules that we have created that essentially describe the semantics of the Symboleo language as reusable modules in the NewXMV. So we have essentially encoded the language to simplify the generation of NewXMV representation. So we're just invoking modules that already exist. We also have ways to restrict the state space. So we can specify ranges of values for specific variables, just to give a chance to the model checker to cope with the complexity of the state space. And obviously we take properties in LTL and CTL. And we feed all of this to NewXMV, which essentially produces outputs for each property. So either it has passed successfully, or a property essentially has failed. So there is some inconsistency between the property and the specification, and counterexamples will be provided in such situations. So those primitive axioms that we have encode the language. So we have created them manually, we have tested them, we have model checked them as well. So those are essentially reusable modules that we're not touching anymore, right? So they work. So we have modules for contracts, for obligations, for powers, for events, and so on. So those are the things that the code we generate will invoke, will instantiate. And then once we parse the contract, we need to generate essentially instances of these things. So we have the obligations and powers from the meat sale example we had earlier. So essentially the code generator that we have will create all of these obligations and permissions as essentially functions that will invoke our trusted reusable modules that I showed in the previous slide.
Then,
yes,
Daniel, we have a few questions. Do you want to take them now or later?
Maybe after the analysis. Okay.
Okay.
So at this point, we have essentially a new XMV representation of the Symboleo contract that was specified. Now we can check properties. So we don't have a specific language for the properties right now. So we're still using LTL and CTL directly. we hope to augment the Symboleo language with ways to specify properties in a more convenient form, because lawyers will have trouble with CTL and LTL. But we can specify sets of properties. For example, making sure that everything is reachable, so all obligations and powers can be activated at some point in the future. This is an example of a failing property. So the property wants to ensure that the delivery of the goods always happens after the payment, and this is not supported by that specification. And actually, probably that the problem here is the property, right? Because I don't mind that payment probably happens after delivery of goods, as long as this is quite short a time afterwards. So those are all things that we can check, and then we can discuss and see, well, do I need to change the specification or the property or both, so that we have a mutual understanding and can align the different views that those two languages bring. We also assess the performance and scalability of this approach. So we created tools to generate contracts randomly, given specific parameters. So we looked at 14 contracts to extract the frequency of the usage of obligations and powers and other concepts in them, so that we could generate randomly realistic contracts, I would say. And we also have a generator that generates LTL and CTL properties for those contracts. And we use that essentially to test the scalability of the tool set that we have. So we can handle, 30 to 40, I would say, independent legal positions, such as obligations and powers. That becomes a bit more complicated when we have a number above that. So it becomes it takes a while for the model checker to find solutions to a set of properties. But for most, I would say, average sizes contracts, right now the tools that we have are good enough, but there's always room for improvement. We also looked at the competition out there. So we have, about a dozen languages here that focus on the specification of contracts using different legal concepts. Most of them will support events and some representation of time, because those are important in contracts. However, where they suffer essentially is in their support for analysis, I would say. Many of them will have fancy concepts supported in the language, for which it's very difficult to provide automated analysis afterwards. So Symboleo seems to strike a good balance between being able to represent various kinds of contracts while enabling automated verification and analysis, and also supporting more advanced concepts such as subcontracting. We also looked at many other approaches to formally model check or verify legal or smart contract techniques. Many of them will focus directly on, for example, the what we call the programming level. So they will try to model check solidity smart contracts directly. Others will focus a bit more at the specification level, like what we do here. And again, the tools that we have to support the analysis of formal contracts in Symboleo compete very well with what is available out there. So Giles, this is my part on the analysis. I will stop here for another 5 minutes of questions.
Okay, so there was a previous question from Amyot Gonçalves. You know him very well. And his question is about if it is possible to represent the Symboleo meta model as a modeling language and propose a model-driven approach to generate textual specification.
Well, Symboleo is a modeling language, right? So, and we do have a meta model for it. The thing is that we're using a textual syntax and not a graphical syntax. So I guess the question here is whether we could have also a graphical syntax for the language, if I understand well.
Okay. Perhaps you can follow on that.
And the answer is yes, right? So we do have, you know, the concepts, and we could have a different, instead of having a textual syntax, we could have a graphical syntax for it.
Yeah.
There are benefits in having a textual syntax because, you know, you can copy paste, you can have intelligent editors. It's faster to create contracts that way, I would say.
Yeah. The other question I think is from Dan Barry. Do your tools check for voidness?
Again, I guess there are two parts of it. So there is a voidness in the sense that nothing can be done with the specification, so it's contradicting itself. And yes, so as soon as you try to check a liveness property, nothing will happen. It will be violated. There is also voidness with respect to the legal system where the contract resides. And right now, as I said, we haven't done that formally yet. So we haven't looked at bringing the jurisdiction obligations and, you know, requirements as properties for the specifications. And the question is always, should I bring the jurisdiction context inside the contract or as properties to be checked against the contract? My feeling is that it should be properties because natural language contracts never say much about the legal system, except that, you know, if there is a dispute, that legal system will be used.
Okay. What about your comment on the difficulty of using LTL and CTL by normal people like lawyers? I mean, you have to have a PhD to use this.
So we are well aware of that issue, right? So I would say that even people with PhDs in computer science usually have a lot of trouble writing LTL and CTL properties correctly. What we want to do essentially is to enable a syntax above it that is contract oriented, and that would help us generate those LTL and CTL properties. Because the kind of properties that we see applicable to contracts, they're often the same. So there are patterns that exist that could be brought to the level of the specification using the terms of the specification rather than the obscure, symbols that we have in CTL and LTL. So yes, we are aware of that issue, and the solution we envision is to have something brought to the level of Symboleo.
Have you been able to have some legal expert in your team, trying to use,
Yes.
What was their impression?
They love this.
So they like it?
Yes. So I'm part of a very large project that involves about 45 professors. It's autonomy through cyber justice technology project. It's one of the largest projects we have from one of the Tri-Council funding organizations in Canada, and we have also representative from all over the world. And so yes, we got lawyers and law professors involved in the verification, the validation of the ontology. We also had some people starting to use this for NLP research, to essentially try to spot those obligations and permissions and assets and roles. So we collaborate with a legal team also from HEC Paris, who is also part of that project. So yes, we have lawyers and law professors and researchers involved.
Great. I think you can go on because you have no.
João has.
Okay, João. Yeah. Hey, brilliant. João, take your time. Open your camera, please.
It's concerning the validation part. How do you have you started the evaluation process together with the users? What they think about the whole approach or the whole framework in the
Not formally. So we have various case studies. So we have a couple of toy examples like the meat sale, right, and pizza delivery, things that people can understand. We also have more serious case studies. One of them is in the transactive energy domain. So transactive energy is when people are not just consuming energy, but also producing energy through the wind, through solar systems, and so on. And in that world, there is an emerging peer-to-peer market where people create contracts for things like, hey, I need that amount of electricity tomorrow morning from 10 to 11 with that quality. So they have very short-lived contracts, very urgent contracts where they don't have the time to involve lawyers, right? And those are the kind of systems that are very much amenable to automatic monitoring as well, because the power grids are becoming more intelligent every day. So they have sensors everywhere to ensure that quality and a quantity of energy is being provided in a timely way. So we're working with a small company in Toronto in that space where we started using this. We also work with a large European corporation interested in using this to check that data sharing obligations are being enforced, things related to GDPR compliance, for example, as the contracts are being subdivided, delegated to subcontractors and so on. They usually lose the trace of who's responsible for what. And our hope is to enable this through this kind of technology.
Okay, thank you.
Okay, Daniel, you can go on.
Okay, so 2 slides on natural language to specifications. So this is what Professor Berry mentioned earlier. So there, we are interested in this. We only started. As I said, we expect that automatic translation will be difficult to have in general. So our real target is to reduce manual effort of converting natural language contracts to our representation. The syntax we have for the language right now is very computer science oriented as well. So we will probably work on making it more accessible to non-computer scientists. We also investigate ways to perhaps have templates that exist for which we already have the mapping to Symboleo, so that people can just select and assemble various clauses together, as most lawyers and notaries are doing with contracts anyway. But we still started looking into extracting essentially different concepts that we have, like obligations, debtors, creditors, assets, roles, parties from contract templates, such that we can simplify essentially the conversion to Symboleo. So more to come next year. The last part is essentially, now that we have a formal specification of a contract in Symboleo that meets or satisfies the various properties that we have model checked, what can we do with it, right? And the question we're trying to answer here is, how do we create monitors that will automatically check whether a contract that executes violates the terms and conditions of the legal contract that we had earlier. So as I mentioned, we are very much interested in doing so in a context where we have cyber physical systems, where we have sensors that will check the temperature of the meat, for example, or the containers where the meat is stored, positioning, right, for understanding locations and inferring knowledge about delivery. So all of these things can be checked through sensors nowadays, and those are sources of events that will essentially help us assess the progress or non-progress of the execution of those contracts. We had to choose a mechanism to support monitoring, and we went with Hyperledger Fabric, which is a common permission platform for smart contracts. Hyperledger Fabric supports several languages, including JavaScript. So we went with JavaScript because it's easier for us. It's a quite mature language as well. And the idea is to reuse what we have done so far. So right now we're here, right? So we have created an editor that checks the IDs. We have seen the Symboleo PC tool that verifies properties. What we're adding now essentially is a way to generate smart contracts in JavaScript for Hyperledger. And for that, we created essentially a compiler with a translator. And for that, we're using Extend, which is a Java dialect and very popular in the Xtext ecosystem. So we have rules essentially to produce smart contracts. And the smart contracts that we generate are quite small because they reuse a platform that is generated semi-automatically from the ontology and the state machines that we have. So at the University of Ottawa, we have developed the AMPL language. So AMPL is a textual language that looks like UML, supports class diagrams and state diagrams. So it's very useful in our context. So we formalized the ontology and the state machines with it. We generated code in Java because JavaScript is not supported yet. And we manually converted it to JavaScript so that we have essentially a library that understands the ontology and the state machines. And we supplemented it with the specific axioms that we have for Symboleo. So essentially the smart contracts are invoking the methods provided in that library. So AMPL is great, as I said. We used it for several purposes to get the ontology. We also used it and the state machines and all the functions that come with transitioning from one state to another. We also used it just as a sanity check for our verification tool that we saw earlier. Because we had done that work on translating the semantics of Symboleo to using the manually, but we reused this to check whether we forgot anything big, and actually we were quite fine. And obviously we also have an EMF representation of the ontology should anyone wants to build another tool for it. So we have this now as a JavaScript library. So this is an obligation. This is the constructor. So the name, the creditor, the debtor, the contract, and all of these things. So this reflects the kind of concepts that we have in the specification itself. As I said, we have created the transformation templates in Extend to produce JavaScript code from Symboleo specifications that were parsed with our Xtext editor. And that generates, readable code for our smart contracts. So this is an asset example here, the perishable good and the meat. And we have templates also for the contract and its obligations itself. So essentially it's quite simple because since we have this library of trusted functions for obligations, powers, assets, events, we simply need to instantiate them now from our specification. Where we had to be quite creative, and this is the thesis of Aydin. Essentially, we needed to have some sort of a runtime execution environment, I would say, that would understand how to create, consume, and pass events around. And we're using, obviously, JavaScript events to do that, but we needed to provide a mapping between the various kinds of events that we have in Symboleo and those in JavaScript, and also what we call transactions in Hyperledger that also produce, consume events, and also put something in the blockchain at some point, right? So we're storing a lot of things in the blockchain along the way, because one benefit of Hyperledger is that it's cheap, right? It's a enterprise level blockchain environment, so it's fewer computers than, for example, the Bitcoin network or the Ethereum network. But you can put a lot of information in the blockchain itself. And we also have, obviously, a lot of event listeners and producers along the way. So independently of the library of JavaScript components we created for the language, we still see in our 3 examples that we've done a 14:1 ratio in favor of Symboleo. So each line of Symboleo contract essentially results in 14 lines of JavaScript code across multiple files along the way. And those lines of code invoke the library that we also created once for the semantics of the language. So there is a good saving essentially to even just use Symboleo as a means to create smart contracts directly for monitoring purpose. We obviously deployed those smart contracts on the Hyperledger platform, and we created many scenarios to check essentially whether they were working or not. And this really helped us debug the code generator along the way. So we have very good results now. Again, we compared this part with related work. So essentially, there are other languages out there or other environments that enable the generation of smart contracts automatically. Very few of them will have the expressiveness that Symboleo provides in terms of real contractual concepts. Power, for example, it's nothing that we have seen in any of these languages. And many of them were essentially created from I would say, a bottom-up approach. So they try to provide languages that would abstract a little bit from JavaScript or Solidity and generate code at that level. Whereas our approach is a little bit more top-down, meaning that we started with an ontology of contracts and created a language around it. So we're a bit better in that sense than those things here. So this is the end of my presentation. We've made several observations while doing this work over the past 4 years. We realized that legal contracts are very complicated artifacts with respect to the legal concepts that they have. And we see them as a bit more complex also than what is typically found in business processes, which is another domain for which many requirements-based modeling languages have been created. So we have must and can, and we can model them with model logics, but this is difficult to do so in a way that enables analysis formally in an efficient way. And our selection of a state-based representation for the semantics of our contracts was a good choice, both for analysis and also for code generation. We have several publications on the topic, should you be interested. So I'm also sharing my presentation. This is from a couple of years ago, so the early days of Symboleo, published at REER, TESC. There was a thesis also that provided the first iteration. But 2 weeks ago, we submitted this PhD thesis, and we're submitting this master's thesis this week, so there is more to come. We have 2 papers on the 2 tools I presented today that will be presented at the Models Conference in October. And we have still a journal paper that is under review. So this is pretty much it. This was my takeaway slide that I put here again. So we're interested in engineering smart contracts and cyber-physical systems to monitor, automate, and control the execution of legal contracts. We created the Symboleo language as a result. We have tools now that support property checking through a conversion to a model checker. And also we have the generation of smart contracts for Hyperledger Fabric in JavaScript. What's next essentially is more on natural language, more focus on quality requirements when generating code, for instance, about security, about distribution of the information, what to put on the blockchain, what to put outside the blockchain, robustness if sensors are failing, for example, and a lot more goodies. So, muito obrigado. Thank you.
Okay. Thank you, Daniel. We have 2 previous questions that were sent, one from Monique Ribeiro, which is about why the choice of Hyperledger Fabric. Is it to reduce cost or for safety? Another one from Dunbury, and then we have 2 other people waiting, with their hands raised.
Yeah, so Hyperledger is an enterprise solution, right? So it's a lot cheaper than using Ethereum, for example, where in Ethereum you have to be very careful about what you put on the blockchain because each usage, each transaction is quite expensive. So yes, to reduce cost definitely is one of the reasons. The other one is that it is a permission environment, so you
not
can
related to safety.
Control. Sorry.
What about the issue of safety?
It's more security than safety, I would say.
Yeah. Okay. So the second question was from Blan before. So he was wondering if you see lawyers learning to write natural language contracts that are easy to convert into a formal spec.
That's one thing that we are considering, right? So essentially provide guidance as to how to write contracts in a way that is compatible with Symboleo. Perhaps even through, as I said, the web-based environment with predefined clauses or paragraphs that can be reused, for which we know in advance what the mapping will be. So we would build or assemble a contract by construction.
I'll hand that to Julio late. We are very short on time. We only have 4 more minutes. So Julio, be very brief.
Daniel, thank you very much. Very, very, very nice work. I see it. It's interesting because my previous question was related to this idea that we had requirements of using the law as a requirement. And now what you have shown from my understanding is a domain language for contracts, right?
Yep.
So in this domain language, you are able to transform it in executable code. So you could, let's say, control the parties that sign the contract. And this into monitoring, control and monitoring. So it's I really like to see this new way of using, using the knowledge, and you have the ontology of law to build the domain language that you present, Symboleo. Very nice work. Thank you very much.
Muito obrigado.
Okay, there's a question from Roxana.
I cannot hear you, Jason. Sorry.
Okay, because I'm using the other computer, I have to. Okay, try again. So, Roxana is thanking you for your nice research, and her question is about the results of the model checker. So, what kind of results?
The model checker that we use essentially says for each property whether it passed or not. And if it doesn't pass, it returns a counterexample that right now is more or less at the level of new XMV. So it would be difficult for a lawyer to understand. So we also have a little mapping back to Symboleo level, but it's not great yet.
Okay, thank you. And the last question, Don Barry, please, can you ask your question? Your mic is muted. Okay.
Yeah. You're using the blockchain to create a permanent, unmodifiable record of what has happened in performance of the contract that all can be trusted, that all can trust. Is that the reason for that?
Well, there are two reasons. One is as you said, the trace of events is stored along the way, and the trace of transactions as well. And the smart contract itself is on the blockchain, so you cannot change the contract midway.
Yeah.
Okay, so with that, we conclude our wonderful keynote speech by Daniel. Now, Amyot, we are very thankful for your time today with us in the middle of your summer vacation, right? Although you say you're not on vacation, so thanks a lot.
Thank you so much.
Okay, we are going to share. We're going to share your slides very soon on the website. Okay, so everyone that is interested can download later today the slides. Thank you.
Thank you so much.
Good.
Take care, everyone.
Okay.